help, technical glitches. So let's begin with our work. Mm, so I think I have already shared the, as usual, means as yesterday, I have shared with you the file problem sheet. But then before that, let's have some quick revision of the topics, and then we will move on to this problem sheet. Okay, so maybe some short revision. Now already we have lost 15 minutes. So let's go ahead. So today's basic topic is differentiability. Differentiability. Okay, and then corresponding important thing is mean value theorems. Okay, so quick questions, like if I have f from R to R, okay, and if I have a point P in R, then f is differentiable at P if, so I'm asking the definition, f is said to be differentiable. So let's try to develop the definition. If, so can somebody complete this? If, what must happen? Yes.
The limit of
Okay, let me write
the
limit of
f of x plus h
okay,
minus f of
f of
x
okay
whole upon h,
upon h
then h tends to
uh,
be like this.
okay, fine. Only thing is, because I'm using p, so I will just change it to p. That's it. So it's correct. So some limit, okay, some limit should exist. Now try to understand. It's basically talking about how this limit has come. This is equivalent to talking about fx minus fp upon x minus p and x tending to p. This limit. So either you say this limit or this limit, it's one and the same thing. I'm just going to replace x minus p by h, and if x is tending to p, this is same as saying h is tending to p. So what this ratio is actually, this ratio represents geometrically, if I look at any function, okay, then so whatever function I want, I can draw a function like this, and I'm actually interested in the slope of the tangent at a specific point. And then what we do actually is look at p and maybe p plus h. So either you can go ahead, or h may be negative, and then try to reduce h. So this slope we are trying for, and this slope is represented by this ratio. So this is point p comma fp, and this will be the point p plus h, or x comma fx, you can say p plus h comma f of p. And then the slope of this chord is what this is. Now as h tends to 0, yeah, x tends to p, this chord starts tending or trying to become a tangent, and in that sense, as a limit, we can obtain the slope of the tangent, and that is nothing but the derivative of the function. So that's perfectly all right. This is a perfect definition. And whenever such a limit exists, so whenever this limit exists, we denote it by, so we denote it by f dash at p, okay, or Sometimes we write it as df by dx at p, whatever. So this would be the standard notations. Now, immediate consequences I would like to write. That is, what should be the first thing? The, the relationship between differentiability and continuity. So, can quickly somebody tell me what is the relationship between differentiability and continuity?
Every differentiable function is continuous.
Correct. Correct. So differentiability is always going to give me continuity, and converse is not true. And you know a typical example. Okay. So what is going to happen? Continuity is there, but differentiability is not there. Then there must be some corner point basically. So you can look at what? You can look at, as a typical example, you have this kind of a function which has got a problem at 0, because at 0 if you look at left side derivative, it's going to be this tangent, okay, slope of this kind of a tangent, whereas if you to take right hand side derivative, it will be slope of this tangent, that will be 1, and here it will be -1. So to be precise, fx equal to mod x creates problem, not differentiable at 0. Let's understand. I mean, if I ask what is its derivative at 1, is it differentiable at 1?
Yes, sir.
I'm just asking. Yes, means so. Just the only problem is I can add one more line, and the only point I wanted to say here is not differentiable only at 1. Basically, it's differentiable everywhere else. So 0 is a problematic point, because at that point there is a kind of corner. Okay. Moving ahead, so continuity is not going to guarantee differentiability in general. Then I can even ask some more things, that is like higher order derivatives. So once you have a function differentiable once, I can try asking whether f dash is differentiable. Is f dash differentiable? If the answer turns out to be yes, then I can talk about f double dash, that is the double derivative or second order derivative of the function, and so on. So I can keep doing this further as much as possible. I can keep calculating the derivative. Now again, there are interesting questions like, I mean, do we have an example? Do we have an example? Okay, such that f dash exists, but f double dash does not. Okay, means can you define a function f in such a way that at certain at a specific point, at one point, okay, derivative is existing but double derivative is not. Will be very specific at a point. So what is the answer to this? Do we have such a function? Yes, no, say something. Or you don't know, whatever, no problem.
It's not reminding now.
No problem. See, so is the question clear? Like I'm asking, once differentiable is there, but twice differentiable नहीं. ऐसा कुछ construct करना है हमें, suppose. We can construct that. So answer is yes. I mean, we can have. Answer is yes. And see, मैं क्या करूँगा? I know now one candidate which is like not differentiable. So after first derivative, if it becomes like this, that is, if I construct a function whose f dash will be this, then I'm done. Understand? So f double dash will not exist at 0 for that matter. So what I will do is, let's see. So if I take f of x, of course there are different ways. So one of the way is I will do it as x into mod x. So what is this? This function is going to be simply x square for x bigger or equal to 0, and minus x square for x negative. Do you understand how this had come?
Yes.
I'm just using definition of mods. That's so I got this. Now, if you actually calculate the derivative, that is f dash at every point, then it will turn out to be this function 2x for x bigger or equal to 0 and minus 2x for x less than 0. All right. And now you can see that this is same as 2 times mod x. So if I look at 0, then this f is differentiable at 0, but not differentiable, I mean, twice at 0. Because graph कैसे होगा, by the way, इसका x square and minus x square means this, and minus x square means it will go like this. Right? So at 0 there is no problem. It's a differentiable function at 0, x mod x. But f dash will have a graph similar to mod x. Only 2 factor is coming, so angle will change. That's it. But the corner point will be there, and that's creating a problem. So this is a function differentiable once but not twice. Right? In fact, several ideas are there. Like I can construct it in this way: f of x is equal to x square for x bigger or equal to 0 and 0 for x less than. Okay, so means this kind of 0 up to 0 for all negative values, it's 0, and after this it is becoming x. So this is differentiable everywhere right now. But if I compute the derivative, it will be something like 2x and 0, f dash x. Okay, and so its graph is going to be 2x is another straight line. This is also a straight. Okay, this will be the graph. And so at 0, it will have a problem. Okay. So these are simple examples, but I want to deal with one more very special example, that is x sine 1 by x for x non-zero and 0 for x equal to 0. Have you worked out with this function before? I'm sure you must have seen this function. Yes, have you seen such a thing?
Yes.
So any knowledge about the behavior of this, because this is important thing as far as even jam is concerned. So क्या होता है ये function? Is it differentiable? At 0, बाकी तो पूछना ही नहीं है. At every other point there is no issue. It's differentiable. Sine 1 by x is differentiable everywhere other than 0. X भी differentiable है, so there is no issue. But only at 0 I have to answer. I have to work out. So is f differentiable? So can you work out? 2 minutes you can take to decide the differentiability. Yes. Apply definition.
Not differentiable.
Ah, good. So you simply apply definition. Limit, say x goes to 0, f of x minus f of 0 upon x minus 0, that is x. And if I work out this, you can see what limit you have to handle. So fx is x sine 1 by x, f of 0 is 0, and upon x, so x and x will get cancelled, and I am remaining with sine 1 by x. And this is another famous limit which we know that it doesn't, I mean, do you know it doesn't exist? Because near 0, it oscillates infinitely many times. Okay. Kyun? Because at every n pi for matter, if I look at x equal to 1 by n pi, right? Then this function is 0 at every 1 by n pi. Okay. So, but then how many such points are there? Infinitely many points near 0, right? So this sine 1 by x becomes 0 at every 1 by n pi. Whereas if you look at 2 by n pi for n, say n odd, then the value is 1. So there are infinitely many points where it is 1 also. And there are infinitely many points where it is going to be minus 1 also. So it will be like huge oscillating kind of a function. And as you go closer to 0, there are more and more oscillations that you are going to have. Okay, so such a behavior sine 1 by x has got, and hence it doesn't exist. So limit does not exist. Okay, so it doesn't exist. So I mean, I can say that this is f not differentiable. That's a correct guess at 0. But then before I move ahead, I have a question. Is it at least continuous
Yes.
at 0? Ah, then yes, the answer is yes, and you can do it simply by sandwiching it. Okay, sandwiching it between x and minus x, because x sine 1 by x behaves like this. This is like y equal to x, and this is y equal to minus x, and it gets sandwiched, the curve gets sandwiched, and hence this is how x sine 1 by x behaves. Same mirror image to this side, and hence it's going to be continuous, okay, at 0, but not differential. Then last part to discuss is about this expression and 0 otherwise. I mean 0 for x equal to 1. Now for this, if you work out fx minus f0 upon x minus 0, this turns out to be x sine 1. Limit x goes to 0. This is what the limit that I have to consider for talking derivative at 0. So x sine 1 by x, limit x goes to 0. What is the answer? It is 0. Right? So interestingly, ये जो function है f of x equal to this is differentiable at 0. And everywhere else it is already differentiable. There is no problem. So f is differentiable on R, equal R. That's the point that one can say about fx. Then I have a question which you can try afterwards. Is so basically that means, and in fact, I can say on full R. So once it is differentiable on R, you can talk about f dash. So question is f dash differentiable at 0? This is the question. Means question is f differentiable twice at 0? This I am not going to discuss now. You can do it afterwards. I hope the question is clear to everybody. Right, so this is important kind of a function that one has to be clear with. Yeah, somebody wants to say something.
Sir, I was asking that is the same the cost.
Actually, no, voice is breaking. So I'm not able to get it. Sorry. Can you repeat your
Happens with the cos 1 by x का function.
same? You want to say same thing will happen with cos 1 by x? Is what your question is? Okay, let me write it. So if I write f of x equal to square cos 1 by for x not equal to 0 and 0 x, right? So one can try again. For cos 1 by x, oscillations are on similar lines that you are going to have. You can mute yourself. Achal, you can mute yourself. That's good. Thank you. So yes, for cos one can you know cook the similar kind of argument and see what happens even for cos 1 by x. Behavior is similar looking like sine, and so we are expecting the similar kind of thing that uh, that should happen for cos 1 by x, but one has to check it out. I have not checked it out. So एक बार बैठ के solve काम करना what happens at near zero. First of all, cos 1 by x का behavior देखना how it behaves. Yeah, it will have similar kind of. Anyway, need to check. So going just to the next quick discussion of mean value. So first thing I want to talk about is Rolle's theorem. So what is this Rolle's theorem? If I have a function, I'll write the starting point, then you can tell me. Such that. So what are the conditions? First, hello, you can speak now.
Continuous and differentiable.
Okay, continuous, but is there any specific domain? Continuous on
Open zero.
closed interval?
Closed
Acha,
zero.
open.
Close zero.
Continuous
Differentiable on open zero.
f differentiable on open is also inner. And third condition is
FA equals FB.
at endpoints it should match. Then I want to say something. It's a quick geometry that can be observed, that you have f of a and f of b same, and the function is differentiable continuity, so no corners and no breaks. So maybe I can draw like this. And so there exists a point where the tangent to the curve at that point is parallel to x-axis, that means slope of the tangent is 0. Such a point we are talking about. So there exists some C between A and B such that f dash at C is C. And sometimes you may have more than one such C. Okay, so there can be more than one, but there will definitely exist one. That's what Rolle's theorem is saying. See why I was insisting upon the uh, the sets on which continuity and differentiability is to be seen, because this is the optimum kind of a requirement. अगर इसमें से मैं एक भी condition कम किया, then I may not be having any guarantee, okay, of such existence of such a C. मतलब closed AB के जगह मैंने अगर open AB किया, then you can try see whether you can construct a function which won't have any C for which f dash C is whatever. Or maybe your differentiability on open AB ke jagah, of course, if I take closed AB, then it is something more that I am assuming, but that's not necessary. Matlab, my question is, like it may happen that I have a function f which is continuous on closed AB, differentiable on open AB, but not differentiable at A or B. Get my point?
Yes.
Does there exist such a function which is continuous on closed interval, differentiable on open interval, but at endpoints it's not differentiable? Such a function can be constructed. Anyone has any idea about how to do this? Because of time constraint, I can't give you. But you see, some function of this type will definitely work. So if I have to say and B, then a circle, half circle basically, then it's continuous, differentiable everywhere. But at A, the tangent is like straight line, A, parallel to y-axis, and so tangent slope won't exist. The limit will be not existing, and hence you can't see. हम लोग ये function. Suppose I ask you, if I would have asked in 12th standard, then we used to write dy by dx. You know, इसका derivative लिखते थे हम लोग. And what was that? 1 by 2 root 1 minus x square into minus 2x. है ना? But we that time never bothered कि ये क्या है? When can we talk about dy by dx? So this is basically this half circle only. इसका ग्राफ निकालेंगे, तो it is going to lie between minus 1. So, and at 1, if I look at derivative at x equal to 1, then it won't exist. Okay, or if I ask it as at plus or minus 1, then this won't exist, right? So that's what the example that I got sharing with you. So it may happen. That is why you don't need on closed differentiability on closed. मतलब क्या? For even for such a function. So that was about Rolle's theorem. Then is the famous LMVT, which is just like Rolle's, only it's little bit generalized. Say. So you have A and B interval, and now one condition is removed, that is f of A and f of B may not be seen. So I may have a function going like this. And then you look at this line. Okay, this point is a comma fa. This point is b comma fb. So this line has got a slope fb minus fa upon b minus a. And the Roth theorem is saying that you can find some point on the curve such that the tangent to the curve at that point is parallel to this line, and hence slope is same. Okay, means at this point, if I look at the derivative, okay, at this point c, if I look at the derivative f dash c, then it will be equal to the slope of this line, because both of them have the same slope. Please understand, this is exactly same as Rolle's. If I move this f of b down to f of a, you will see the whole thing gets rotated and you are getting a situation of Rolle's theorem. All right, there are 2 points in this case with same requirement. So LMBT says f from AB to R, and with first and second condition, then there exists C such that f dash C is S. All right. Then I don't want to get into Cauchy and all, but this gives rise to lot of things, which let me now assume that you know, like increasing, decreasing the criteria, second derivative test, all these things can be derived now further. But moving ahead, एक बात हम अभी यहाँ पर देखते हैं. So suppose my b is x. Okay, I am just denoting the end point as x. Then what I can write is fx minus fa upon x minus a is f dash at c. That means I can write f of x as, so f of a I can take it to this side, plus x minus a times f dash c. All right. This is your beginning of Taylor's theorem. Okay. If I am trying, you know now already that there is a Taylor's theorem. So this is like first order Taylor's expansion that one can have. So up to f dash. Okay. Now, since I have uttered this word Taylor's expansion, let us quickly recall Taylor's expansion. A very powerful Taylor series expansion. Okay. So if I have a function f, there are a lot of assumptions. So I can say right now for convenience, n number of times differentiable or infinitely many times differentiable. Differentiable infinitely many times. Infinitely many times for convenience. And say at a particular point, at a or infinitely many times on r, and I am fixing some a. Then interesting, what is the benefit? If I know f of a, if I know f dash a, if I know f double dash a, if I know only these terms, f triple dash a, सिर्फ इतनी वैल्यूज पता है मुझे, बाकी फंक्शन पता नहीं है, then I can retrieve the function fx in some neighborhood of a. That is, there exists some neighborhood of a such that f of x can be expressed as a combination of fa, f dash a, f double dash a, f triple dash a, and so on. So the combination is precisely this: x minus a divided by 1 factorial, x minus a square by 2 factorial, f double dash a, and so on. Plus, Now, when I say and so on, it's very risky because that means I'm talking about infinite series. And then there is a question of convergence. Okay, so one can actually prove precisely that there exists a radius of convergence in which f of x will be expressed like this for every x. That is, this series, right hand side series, converges and it converges to f of x. Right? This can be proved precisely, but one can terminate it in between. And whenever you stop in between, say nth term, suppose I'm talking about nth term, then I mean term is n plus 1, nth power term. Then I can adjust the error by saying there is some c which will be lying between a and x such that this will be equal, f of x equal to this one. ठीक है, तो अगर हम फाइनाइटली मेनी टर्म्स में रुकना चाह रहे हैं और इक्वल टू लिखना चाहते हैं, then the error adjustment is happening at the last term. Now this is again useful, and there is always going to be a question of Taylor's expansion, because that it's one of the most important topic as far as differentiability is concerned. Right. So I suppose I've done enough things. I'm more keen to talk about problems. So you have the problem sheet with you. Let me also open the problem sheet, and we will move to problem solving. Work. Yeah. So let's get into first question itself. We'll do first, second, then these are already done. 5, 6, what to do? Simply plot for first. First, if you are done, you can put in the chat. I did not see it. One is not mute. I think Pragati. Can you mute yourself? So what is the graph of first? Mod x less than or equal to 1 के लिए 0 है. So पहले मैं इसका ग्राफ प्लॉट करूँ. Mod x minus 1 in general. So if I try to plot the graph of, so this is mod x. Then minus 1 जब मैं कहूँगा तो this will come down by 1 unit. So mod x minus 1 will have a graph like this. Right? This is a graph of mod x minus 1. Now the thing is our graph. So what is our graph? Our graph is up to mod x less or equal to 1, that is between minus 1 and 1, the graph is 0. So minus 1 to 1, the graph is this, and afterwards it is this mod x minus 1. Mod x minus 1 ऐसे जाता है. So what is happening? It's the function is not going to be differentiable at wherever there is a corner point. So what are the corner points? Minus 1 and 1 are the problematic points. So your answer is going to be differentiable at 0, but not. Okay. Go ahead. Second. Yeah, you can message me privately so that others will not stop thinking about the solution. Huh? answer to second. So second, I will just move to next page and see. Yeah. So how do we deal with this? So it's differentiable function. So in particular, it's differentiable at 0. And so in particular, it's continuous at, isn't it? So that means this limit extends to 0 of f of x is f of 0. Now, how much is f of 0? Tell me. F of 0.
0.
0, because you see this is the rule. So b times 0. So this limit is 0. But then I can try left side limit. So that means limit x tends to 0 negative of fx. That is a sin x minus 2x on x का limit 0. But this you can compute independently. So what this will be? Sin x by x is 1. So a minus x by x is 1. So a minus 2 is 0. And that tells me a is 2. You understand this? Okay. So you got a. Now I have to use differentiability. So differentiability means to get b. So if that means f differentiable means limit x tends to 0 of fx minus f0, but f0 is 0 upon x. This exists is what we know, since f is differentiable at 0. Right? So work this out. This means limit x goes to 0 minus of fx by x, that is a पता है हमको अभी क्या है, 2 sin x minus 2x on x, the whole thing divided by x. So I can write this as x square is equal to limit x goes to 0 plus of fx, that is bx, isn't it? Bx minus 0, so upon x. X is gone. So this will give you value of b. So let's compute that. So I have to compute this limit. Now how do I do this? कैसे करेंगे compute? 0 पुट करेंगे तो प्रॉब्लम. So what do I do? Come on, how do you calculate this limit?
L'Hopital's rule.
L'Hopital's rule. Apply. So 2 cos x minus 2 divided by 2x, limit x tends to 0 minus. Now again it is 0 by 0. Cos 0 is 1, so 2 minus 2 upon 0. So once again L'Hopital rule. So 2 cos का minus 2 sine. This is 0 upon 2. And now this is 0. So this is my value of b. Right. So answer is yes, B. Good. Good. Some of you are getting the answers. Go ahead. Fifth, sixth. So what to do with this? Whenever such a thing is asked, what we have to simply do?
Continuity at that point.
Continuity, but if it is asked in two parts, then what are the only points where it might be differentiable?
Possible at intersection, but there is not an after intersection.
So I mean, I just need to solve kind of this. And if you can get some x, so I don't know, let me try. This is equivalent minus 3x plus 2. X minus 1 minus 2. Right? So x is 1. So at these points only, the function will be differentiable. Because this curve, as a curve independently, it has got no issue of No, this will give me continuity. डेरिवेटिव के लिए हमें इंडिपेंडेंटली डेरिवेटिव लेके रखना पड़ेगा. So this is continuity. For differentiability, I have to work out separately. So this will be 2 and 2x minus 1. So 2x minus 1 should have 2. So it's so no point is a point of differentiability. I don't think any of the points will have, because there are only two candidates, one या फिर two, जिसमें से because continuity सिर्फ इन दोनों पे ही due to rational irrational. जब ये intersect होंगे, only those points are points of continuity. So one or so that means question is whether one is a point of difference. That's the only. Zero is definitely not, because zero पे continuity नहीं है. So no question of difference. Now at 1 I just have to see, but then what will happen? At 1, did I get? I won't be getting that. Okay, the tangent along this curve will have a slope as 2 minus 1, that is 1, whereas tangent along this curve will have a slope 2. And hence you won't get a common tangent as such. So it won't work. Unfortunately, no differentiability.
Sir,
I guess this.
sir, the function is continuous at x equal to 3 by 2, right?
No, because continuity, then these two should match. No? So
Yes.
if I solve, so have I made any mistake in this computation? Just check. 2x plus 1 equal to this. So if I simplify, I get only these 2 points as points of continuity, right? Yeah. I know.
Then that f dash is continuous at x 3 by 2, only 3 by 2.
No. See, problem will be what f dash 3 by 2 आ रहा है, but 3 by 2 जब मैं f dash मैच कर रहा हूँ तो आ रहा है, but उसके लिए पहले मेरा f तो continuous होना चाहिए. So that won't work. Means ultimately f dash won't be existing at any point. Means f won't be differentiable at any point. That's it. Because even at 3 by 2 I may get equal values of the tangents, but there is a discontinuity at 3 by 2. You realize what I'm saying? Curve का behavior match हो रहा है, but discontinuity is there, so you can't still say 3 by 2 is point of differentiability. Listen, तो differentiability के candidates दो ही थे अपने पास, या तो 1 या 2, right? जिसमें से 1 पे हम चेक कर सकते हैं कि वो कर्व का वैल्यूज, मतलब टेंजेंट के वैल्यूज मैच नहीं करता along any of the curves, and hence gone means I can't have equal 0 for this particular is that all right? So now let me go back. Catch up 6th. Six, any idea?
So we know that f inverse f is invertible मतलब ऐसे दिया है तो अभी हम लोग कंसिडर करते हैं कि f invertible है.
Yes,
Now,
yes, F is in.
yeah, so now f composed with f inverse will be identity, right? Yeah. So it is actually equal to f. So what we can do is to find differential. So we can apply chain rule so that we can get
Right,
f inverse of 2 from this expression,
hmm,
and we can then compute g of f inverse at 2, like by applying chain rule.
correct, correct. Yes, yes, yes. Good, very good. So go ahead. I think for others I can explain what he has said just now. So basically G composite F inverse, I want derivative of G composite F inverse at a point 2. Chain rule says that this is equal to, yes, somebody, G dash at F inverse 2, huh, into F inverse dash at 2. Do you know this? Huh? GOF dash at any x is G dash at fx into f dash x. यही है ना? तो f का रोल प्ले कर रहा है f inverse, that's it. So I am just writing chain rule. Now what? Now let's look at this first. I know gx, x cube minus x. So I know g dash x, 3x square minus 1. Now can you guess f inverse by looking at fx? Fx is x cube plus x. So for which x you get f of x equal to 2? Okay, 1, correct. So I have got f inverse 2 as 1. And so I can get g dash at f inverse 2 is simply g dash at 1, that is 3 minus 1. So I got it as 2. So इसका आंसर आ गया. This is 2. Now look at f inverse dash at 2. Now how do I do that? As he said, f inverse composite f of x in general is x. So derivative, that is f inverse compose f dash at x, is always 1. So in that sense, you have f inverse of fx, f inverse dash of fx into f dash x is 1, and this tells me f inverse dash at fx is equal to 1 upon f dash x. right? So if I want f inverse dash at 2, then what is this 2? 2 we know it is f of 1. So this x is actually 1. So f inverse dash at 2 is simply 1 upon f dash at 1. So this is simply equal to 1 upon f dash of 1. Now can you get f dash 1? F dash x is 3x square plus 1. So f dash 1 is 4. So 1 by that is 1 by 4. So 2 by 4, that is 1 by 4. That's good. Some of you have already got the answer. That's good. So it's a nice application for chain rule. Now, eighth, don't disclose. You can put the answer on private chat. Yes, eighth. Eighth is interesting. Simply go by definition. First of all, can you guess f of 1? What will be f of 1? fine, because differentiability is always going to guarantee continuity. So if you have a sequence, this is a sequence, I can say xn. What is happening? Xn is such that xn is converging to 1. 1 plus 1 by n goes to 1. This should imply f of xn should converge to f of 1. But what is f of xn? F of xn is constant sequence 1, right? And I am saying that it must converge to f of 1. But constant sequence 1 converges to 1. So this tells me that f of 1 has to be 1. First observation. Now look at for f dash 1, what limit will you consider? Limit now, and then it is existing. So I can simply write f dash 1 is equal to limit say x goes to 1 of x minus f1 upon x minus 1. Right? So what do I do? कैसे निकालेंगे ये लिमिट? I am saying that the limit exists is what we know. So whenever we know that limit is existing, what we simply have to, what we can do is, see, function के सारे values पता नहीं है हमें, so I can't replace f of x for any given x, but I know the value of the function at specific sequence, which is converging to 1. Okay, so I can write that this is same as limit n tend to infinity f of xn minus f of 1 upon xn minus 1. You understand? For every xn, sequence xn, which is converging to 1. This is true. Are you getting this? This is sequential result for limit in general, that whenever limit x goes to p, f of x is L. Whenever the limit exists, this is if and only if for every sequence xn converging to p, we must have f of xn to converge to L. Okay, and it's if and only if. So now I know limit exists. So if I want to compute that limit, I can take help of a sequence. And now you are done. Because what sequence I will choose, this is true for every sequence. Naturally, I will choose this. So at that sequence, I know function value is 1 and f of 1 is also 1 upon xn minus 1. So limit n tend to infinity, and this will be 0. Right? Because this is non-zero. It's 1 by n. It's a non-zero quantity, and that won't be trouble because I know limit exists. Please, I repeat that I know already that limit is exists. So I can do this and declare that the answer is 2. So f dash 1 is 0. Okay, so answer.
But what about the denominator xn minus 1?
How? That is the point. I'm saying that I don't have to be worried about xn minus 1 because I already know that my function is differentiable and the limit exists. So I don't have to be worried about 0 by 0 or something. So that point will not be arise. I am having my numerator 0, 1 minus 1 precisely. And so this is like 0 upon some non-zero quantity is what the expression is. Okay, so I will do one more step. We can write it as limit n tend to infinity of 0 upon something, but that is 0 only. So before I apply limit, I am writing it because my numerator has become 0 beforehand. See, till this step I have not applied limit. ये 1 मैंने लिखा है because of this information. So my numerator became 0, denominator is non-zero, and so the ratio is nothing but 0. And now I am taking limit, so answer is. All right. Is this point clear? No, actually, I don't want to just stop at f dash 1. In fact, I want to ask what is f double dash 1? Can I compute f double dash at 1 from the given information? Huh? f double dash 1 compute हो सकता है. Actually, yes, we can compute f double dash 1 also. How do we go for that? Can you imagine? Because instead of f double dash we put some. What will be f double dash? Limit x tends to 1 of f dash at x minus f dash at 1 upon x. Now this is 0. F dash 1 is 0, I know. So I have to calculate this limit. X goes to 1 of f dash x upon x. Now again, problem is I don't know f dash x. But I know this. I know this. So if I call this as xn, I know f of xn is 1. Now will this gives us some information about f dash at some points at least. So 1 and 2. F of 1 is 1. F of 2 is also same height. F of 3 by 2 is also 1. F of 1 plus 1 by 3 is also 1. And so on. Now what can you say about the derivative then? Like between these two, what can you say about the derivative? Rolle's theorem, हाँ? हमने डिस्कस किया ना Rolle's theorem. So you are having same situation here at multiple intervals. So between 3 by 2 and 2, Rolle's theorem की वजह से there is some y1. So between x n plus 1 and xn, in general, right? There exists some yn such that f dash yn is 0. Can I say this? Any 2 points, because f at these 2 points is 0. F of xn is 0. I mean 1, sorry, 1. So at both the points, f takes same value. F of xn plus 1 and f of xn is same. So by Rolle's theorem, between these two, there exists some term such that f dash at that point is 0. So xn plus 1 less than yn less than xn is the situation for all n. Now xn is converging to 1. Xn plus 1 is also converging to 1. So yn has no choice, it has to go to 1. Right? And f dash yn is 0. Now we have enough information. So I can replace this as limit n tend to infinity f dash yn upon yn minus 1. Because yn is a sequence. This is true for every yn. Converging to 1. Okay. So in particular, हमारा yn के लिए भी ये true है, but हमारे yn के लिए numerator will become 0, and hence this whole thing will be 0. So f double dash at 1 also will be 0. That's something very beautiful. So f double dash 1. Let's see how. So I'm applying the rules here. Infinite times. Maybe we go to another page. You can look at 14. Say maybe 19 we'll see. Many have to discuss some points, but time. Let's see. 40 should not take so much time. Yes. Phi dash is increasing means what? So what will be phi dash x for x bigger than 1? Can I say phi dash x greater than 0 or all x greater than 1? Increasing है ना? And at 1 it is 0. So if x is bigger than 1, phi dash is positive. But phi dash is positive means phi is increasing after 1. So it is increasing on 2 to 3. तो अगर इंक्रीजिंग फंक्शन है तो उसका इन्फीमम 2 पे है और सुप्रीमम 3 पे है. So actually it's alpha infimum है ना, minimum. So alpha will be phi of theta will be phi of 3. That's it. अभी जो करेक्ट है वो देखो. Yes. Is it okay? That's why people are correct. Some of you have got correct answer. Theta is equal to phi of 3. Let's look at 19. So what is Maclaurin's? Taylor series. Don't see. So what will be coefficient of 1 x raised to 125? If I take this as my function fx, then coefficient of x raised to 125 is going to be that term f 125th derivative at 0 divided by 125 factorial, which is given as 28 upon 124 factorial. तो ये कंप्यूट करना है आपको बस 125th derivative at 0. Can you get it?
Zero to the power.
Someone is unmuted. Achal, you can mute. So what is? Please tell me 125th derivative. दो तीन निकालो पहले तो आपको आइडिया आएगा. E raised to x plus alpha cube plus 125. Isn't it? Please correct me if I'm wrong. So at 0 कितना है? Alpha cube plus 125. So put that over here, simplify and get alpha. So bit easy. It's okay, you can. Of course, your answer if you are done. What will you do for this? GN3 बोला manageable, isn't it? GN of 3 is so I write it as f of 3 plus 5 by n minus f of 3 plus f of 3 minus f of 3 minus 2 by n. और ये जो n है I will take it down as 1 by n. So instead of 1 I would like to take it as pi by n, this quantity like h, but 5 अगर मैं नीचे ले रहा हूं तो ऊपर लेना पड़ेगा 5. Same thing here, 2 and then 2 by n. And now if I take a limit n tend to infinity of gn of 3, what will happen? I already know that f is differentiable function. Understand? So this will be 5 and this is precisely f dash 3 because your h is going to 0, right? So again limit along sequence is what the technique, plus 2 into f dash. So this is 7 into f dash 3, that is 18, right? So finally right. Twenty-fourth I'll just quickly discuss and then we'll find out. So, Yes, any answer. Uh, then you can put it in the chat box. Or you can unmute and speak. People are getting some yes, that is A. But can you think about some reasoning for this? If it is A, what is it? How do I justify? Hmm? You tell me whether I'm correct. Huh? I'm just right giving some reasoning. F differentiable implies F continuous. 1 by n goes to 0, so convergent. Hence, f of 1 by n is also convergent. Can I say this is the reasoning for why A is true? If I want to say A is true, कि इसमें कुछ प्रॉब्लम है. Hello, are you there? Ah,
Hello, sir.
yes.
Yeah, actually, I haven't solved it by this method. I have taken this is given mod of f dash of x is less than 1. So from there, I have taken -1 less than equal to f dash of x less than equal to 1. But function is differentiable on 0 to 1. So I have taken that f dash is lying between 0 and 1. And then in the integrated over x. So I got 0 less than f of x less than x. And we have been asked about f of 1 by n. So I took f of 1 by n. So I got it as 0 less than f of 1 by n less than 1 by n. So 1 by n tends to 0. So by sandwich theorem, I got it as f of 1 by n is tending converging to 0.
Yeah, that is okay. But the problem, is I have no information about f dash x other than that it lies between -1 and 1. So I may not be able to take it between 0 and 1. So जो आपने कहा ना कि 0 less than f dash. See, f lies with f का domain 0 1, right? But f dash, f dash का domain 0 1 है, but it's the images may not be falling between. Have you said this, or you said about x? I could not hear you properly.
Yeah, I had said this 0 less than f dash of x, but now I realize that f is differentiable on 0 and 1.
Ah, no problem. So that may not be workable. And even this is wrong. You can make out easily because differentiability is not given at 0. So continuity at 0 is not available. So there is no point in saying this because to say f of 1 by n is convergent, I need continuity of f at 0. So this is totally wrong. to play with. But then somewhere we need to use this. So I'll just give a hint. If I try to show that this is Cauchy sequence, like an and am, I mean, let's see whether we can manipulate this. So this is like 1 by f of 1 by n minus f of 1 by n. Can we control this at least? So now you apply LMVT on the interval 1 by n, 1 by m. So what you get is f dash of c, say nm maybe, is equal to f of 1 by n minus f of 1 by m upon 1 by n minus 1 by m. So I can take it to the other side and write this as equal to, rather, equal to mod f dash of c and m. nm लिख रहा हूँ क्योंकि that c may depend upon n and m into mod 1 by n minus. Now you see this is bounded. This is less than 1. 1 times this. And now this can be made less than epsilon for arbitrary, for any given epsilon. I can find some n naught such that this difference is less than, because 1 by n is a Cauchy sequence. So this an becomes Cauchy sequence, right? In R, क्योंकि codomain R है, domain open 0 1, but an is a sequence in R, and R is complete. Means every Cauchy sequence is converged in R. So the reason is, I mean, my an sequence an will be converged. Is the point okay? So there is a small one care that one has to take. You can't play with this like this. This is not the very sorry for those 10-15 minutes loss, but that we can't help. Shall I stop sharing?
If your problems are remaining, you can continue, Mandar.
No, but I have some other commitment.
Okay, no, not an issue. Okay. Okay.
Need to buy. So no problem. They have the question sets with them. So they can
Okay.
try.
Okay. If you can send the PDF of this material also, that will be helpful.
Yeah, writing notes, right? These
Yes.
notes. I'll send.
Okay. Thanks.
I'll send
Mandar.
the PDF.
Okay. Okay, then I think we can
So I'll
wind off
stop.
for today.
Yeah.
So on behalf of NES Ratnam College, Ruia College and KC College, I thank Professor Mandar for conducting two very wonderful sessions on limits, continuity and differentiability. Thank you, Mandar. Thank you all the students for appearing. We will have
Yeah,
our
the
next session
participants
on
were
Monday.
nice.
So please join the session on Monday using the same link on the same time. Thank you. I think we can stop the meeting now. Thanks.
Bye everyone. All the best.
Excuse me, ma'am. Hello.
Yes,
Ma'am, what will be the topic for Monday?
I will put it on the group.
Okay,
Let me
okay.
get the confirmation from the resource person.
Yes.
I will put the topic accordingly on the group. Okay.
Thank you, ma'am.
Well.
Have a good day. Bye.